Thank you very much, Teresa. The parts of that I understood sounded quite nice. And quite accurate. The world of marketing does sort of divide along these lines that Teresa describes. And so that's what we're going to talk about today, are the ways in which, as modelers, we are trying to work with the different kinds of data we have in marketing. So we'll start with sort of a history of marketing analytics, not because I am a marketing historian, but because it's an important part of understanding the full story, how we arrived here. For those of you who are students of history and know the sort of Hegelian dialectic of thesis, antithesis, and synthesis, we are headed to that point in marketing analytics. So we'll talk about two paradigms of measuring marketing effectiveness. One focused on sort of the one-to-one journey, where we are looking at each touch point of a user's path, and another where we are looking at summary data to understand what's effective and what's not. And then we'll talk about the rise of what we are seeing in the United States is really a duopoly or triopoly, and how that is creating difficulties for marketers, and then how people like me and my students and my colleagues are trying to resolve those issues. So just a little introduction. I've worked in marketing analytics for 20 years. I call myself an accidental data scientist. I ended up in mathematics because I didn't like lab classes in biology, which is what I wanted to do, and I wanted a science degree without having to sit in labs, and math worked. And then I did a master's in math and then a PhD in statistics. I did the PhD in statistics while working in marketing, which is probably the only way that I could have survived the process, because I really need to be doing applications in order to engage. Jackie Moore, who many of you may know, was on my PhD committee, and in several very real senses, I owe the fact that I am standing here to her. So as many people here in Montevideo have experienced what she can do for your companies, your career, your job, the same is true for me. And now we're good friends and colleagues at the University of Montana. I started working at the University of Montana in 2014, and I have been working on our marketing analytics and business analytics degree since then. So I teach a few classes in the core of that, and then I teach a class called Telling Stories with Data, which I am getting to teach here. And then finally, I co-wrote a book called Algorithms for Data Science, which is really about taking sort of the fundamental algorithms of statistics and machine learning and trying to apply them from first principles to data. En un profundo agradecimiento a ORT por la invitación. Hablo un poquito español, pero no puedo give the talk in Spanish. So, see, that's exactly where the boundaries of my Spanish lie. So let's talk about marketing analytics history. And this may be a review for some of you, but this will put us all on a common foundation. And we'll also tell you how we think about marketing analytics, where I sort of practice it. So I would say in the 1950s, we saw the beginning of media mix modeling. So that was really the application of what we would call econometric models to summary level information. And when media mix modeling began, it was working with summary level information at maybe the quarterly level. So in the US, you would spend a couple $1 million on television across the entire country. There were only 3 channels, so it was pretty easy to figure out where it went. And you would put that into a model with revenue from stores and try to understand the performance. And then in the late 90s, early 2000s, we saw the rise of online advertising. So I started in online advertising in 1999. So I used google.stanford.edu to answer a question about t-tests on a client call. That was before I had my statistics degree, and I didn't really know the answer to the question. But in that era, right, we did not have search marketing. We had email marketing. We had the beginnings of display. We didn't have any sort of social media or anything like that. People were surfing the web on dial-up, so they saw very few advertisements. And campaign budgets were quite small, right? We would see advertisers like Unilever spend a couple $100,000 in a year. Say, let's just try this internet thing. People say it's going to be a big deal. And what that meant was that if I showed you an advertisement and then you showed up on a website and purchased, I knew that that was the advertising on the internet you had been exposed to. So we saw the rise of what we call the last ad standard, and I'll talk about that in a little bit more detail. After that, sort of 2006, we started to see an explosion of budgets. There was probably year-over-year growth of 20 to 50% in advertising budgets online. We saw a profusion of channels. Paid social started around this time. And we saw things like video and rich media. And we had people surfing with broadband. This was before the sort of cross-device sort of revolution began. Smartphones were just beginning to become really popular. And the sort of data landscape was, here's our plan. We are going to track everything we can track. We're going to store everything we can store. And now let's see if we can do something smart with all of that data. And there was this sort of dream that I would have every single touch point that you had received, and I would somehow be able to put those together in a smart way. And this is the point where we just kind of waved our hands and we said, oh, we'll figure that out. But first, let's just track everything. And this is where, in 2006, the company I was working for, which was called Aquantive, launched engagement mapping. And so this was the first multi-touch attribution algorithm. And I worked on that as a statistician and as a developer. And so we'll talk about kind of what multi-touch attribution is. But this is where it sort of started, was 2006. And then 2008 to 2012, this is where this idea of track everything, sort of store everything, and try to make sense of that data kind of reached its sort of heyday or apotheosis. And this is, I call it attribution DevOps, because at this point we understood what we were trying to do, and it was just a question of having enough storage, making the machines do it, and kind of making everything work, basically. And we saw on the attribution side heuristic models. So rather than I look at the last ad you saw, maybe I'll just take every ad you saw and they all get the same amount of credit. That's not a great model, but it's better than just the last ad. And so we were sort of making incremental progress. And then 2012 to 2016, we saw the sort of rise of what I'm going to call the MTA or multi-touch attribution pure plays. So these were companies, and all they did was try to make better decisions with that granular data. And we'll talk about the fates of many of those companies. And the fates, it's a happy story, so don't, it's early in the morning for sad stories. But many of them got acquired by very large companies. And so I think if you asked someone in 2016, what would marketing analytics look like in the future, they would say, oh, we are going to do a better and better job understanding where people go on the internet, showing them ads, measuring those ads through statistical models, and attributing those results. Since then, this is sort of the coming down the crest of high expectations. We see an emerging duopoly or triopoly between Facebook, Google, and starting today, Amazon. And that presents challenges for our plan that we've worked for the last 10 years. And so we'll talk about kind of how we try to bring media mix modeling like a zombie sort of back from the dead. For 15 years, nobody talked about media mix modeling in conferences that I went to, and now it is becoming very popular again. And so the question is, how do we leverage the strengths of each type of model and knit them together? So that's basically kind of what we're going to be talking about today. So let's start with what is multi-touch attribution. Right, so you imagine we have a bunch of people who are surfing the web, they're being exposed to ads, and we see them purchase, right? So here are 5 people who make purchases, and with the last ad standard, we would see the purchase happen because you can have tags on the website of the advertiser, and you would go back through the record, and you would just look for the first thing you could find. And if it was close enough, you would give that all of the credit. And when we say all of the credit, that means if this person spent $100, we would say, okay, this ad was worth $100. It generated $100 return on investment. The reality in the sort of mid-2000s, kind of the modern era, is that we have a much more complicated digital marketing landscape. People are being exposed to many ads, and one thing that I have not depicted here, but is an important consideration now, is the multitude of devices, right? I have my phone in my bag, and I can use that to surf the web, and I have a browser on my laptop. And for me, those are the only two, but many people also have a tablet. Tablet users, or people who are using tablets, behave fundamentally differently from people on smartphones and people on computers. So we also have to think about the cross-device problem. So even this picture doesn't capture the complexity of what's really happening as people are exposed to advertising. So multi-touch attribution, we're just going to sort of go over each sort of aspect of kind of why we loved multi-touch attribution and why many people still love it today. So when you think about multi-touch attribution, or MTA, and those of you who are practitioners in marketing know that we just love acronyms. We have to use acronyms. And so I will probably say MTA and MMM. But when I say MTA, I mean multi-touch attribution. So we have sort of atomic user-level data, right? We want to see that this cookie 123 saw this particular ad on this website at this time, and they clicked or did not click. They did a search, and they clicked on a paid search ad. The modeling approach, there are a couple different ones, and I'm going to give you just a taste of sort of what those models look like. But it's things like logistic regression and survival models, things like Markov models, or there's sort of a game theoretic approach to modeling these kinds of data. The data grain, sort of the granularity we talk about, requires this sort of consistent cross-device identifier. Google and Facebook have, at least in my world, have the best cross-device identifier, right? Everybody that I know has a Gmail account, and they have that on their phone, and they have that on their computer, and they can use that to tell that my smartphone is owned by the same person that owns my laptop. The results, and this is probably why it's most exciting for advertisers, is that if you do multi-touch attribution, you can understand performance down to the level of the keyword on search, so an individual word being searched and clicked on, or an individual ad on display or paid social, or a single email that is being sent out to a part of your list. And that's why people get excited, right? At this point in digital marketing, much of the results come from that last couple percent, right? If you can take a campaign and improve the performance by 1 or 2%, you can make a lot of money for people, or at least get much better performance. So the purpose of multi-touch attribution is to determine credit allocation and therefore cost per action or return on ad spend at a very low level. And then for forecasting, you know, this is kind of an interesting question, right? So, I mean, at Unilever, right, if you think about, okay, we're going to evaluate decreasing spend by 5% or increasing it by 5%, it's very unclear how you would forecast out of a multi-touch attribution model. Right? If you think about it, everybody is sort of generating their own paths, their own history through the data. And if you wanted to see what the future might look like, you would have to somehow simulate those futures and then run them through the algorithm retrospectively. And the number of assumptions you have to make in order to pull that off make it a real challenge to trust your results. And so forecasting is a real weakness of multi-touch attribution. So talking about a few of the firms, Atlas is the division of a quantive that I worked for. We were sort of founded as a division in 2001, and we were acquired by Microsoft in 2007. At the time, we were Microsoft's largest acquisition. We also became the largest dollar amount that Microsoft ever wrote off in a quarter, I think until Nokia. So we were responsible both for Microsoft spending $6 billion and also for them writing off a little more than $5 billion. Which is an unusual sort of claim to fame. There's a company called Odometry. They were founded in 2005 and purchased by Google. I don't know the purchase price, but I suspect it's in the sort of high hundreds of millions or around $1 billion. Visual IQ uses an agent-based model to do multi-touch attribution, and they were acquired by Nielsen in 2017. A company called Market Share or Market Share Partners, founded in 2005, acquired by Neustar. And if you're interested in marketing technology, this is the only time I will mention them, but Neustar is very interesting. They have gone from a relatively small footprint in the US to acquiring their way to significant prominence. So they are worth kind of keeping an eye on. There was a company called Clear Sailing, which has clearly the dumbest name on this list, I think. I mean, it's hard to say, you know, tech companies have a lot of stupid names. But Clear Sailing was founded in 2006 and then acquired by eBay. And then Convertro, founded in 2009, acquired by AOL in 2014. And then C3 Metrics, founded in 2008, and we say they sort of lost at musical chairs. They were like just a little late and never got acquired, probably much to the chagrin of the money managers for the CEO. So all of these companies were sort of acquired by big companies, and you can sort of look at the years when this happened. And the timing is not accidental. I think 2014 was really sort of the peak of expectations for multi-touch attribution. And everybody was like, okay, if we are going to be smart with our data and smart with our marketing, we need a company that specializes in this. And so all of these companies, except for C3, got snapped up. This is from a Forrester report and is going to be absolutely illegible for those of you in the back, I'm afraid. It actually projects a little better than I thought. But they do these charts on strategy on the horizontal axis and current offering, so sort of currently what does the product look like on the vertical. And you can see Visual IQ, Convertro, Google is a odometry here, market share, eBay. You know, these companies, Marketing Evolution we'll talk about in a little bit, but these companies were all sort of narrowing in on that upper right corner, which since we are sitting in a business school, you know that's the corner of the graph to be in, right? Like the hockey sticks kind of end up over there. When we do quadrants, that's probably the good one. So Forrester is no different, and we saw this sort of grouping in the upper corner. So I mentioned that, you know, there are two broad classes of models. So we have the multi-touch attribution model, so granular data, granular decisions, hard to forecast, and some challenges in terms of the data. Then we also have a media mix model, right? And so let's compare the multi-touch attribution model to the media mix model. So the multi-touch attribution model uses summary level information, right? So back in the 1950s, this was television spend by, in the US, DMA, designated market area, print spending, out-of-home spending, things like that. Now we can work with much more granular data. We have the ability to understand marketing delivery at a more granular level, and we have the ability to work with data at that volume, and we have modeling techniques that would allow us to build models of data of that size. So when I talk about sort of aggregated granular data, imagine in the US, data by day, by state, by maybe channel and subchannel. So search, but not just search, but branded search, right? Where somebody has put the ORT name in the search term, ORT business degree, and searched for it, versus unbranded search, where someone just searches for business degree. So we can have data at this very granular level, and we can work with it with media mix modeling. In terms of the modeling approach, you know, we have a number of options on the multi-touch attribution side. For media mix modeling, think regression, think econometric modeling, right? The sort of time series type modeling where we want to look at how the data varies over time and how these external causes change the response. And when you sort of think of the response, think of key business indicators, right? Revenue, profit, number of customers, number of sales, those kinds of things. So regression modeling with granular data across a bunch of channels. The data grain, you know, this is something that's nice. This can include non-addressable media, right? So Teresa spoke about one-to-one marketing. When we say one-to-one marketing, this is addressable, right? Luis, I want to go out for coffee with you. I am asking you to go out for coffee, right? That is one-to-one, right? All of you, I would like to go out to coffee with all of you. That is non-addressable. It's a little vague, but I do mean it. I would love to have coffee with you. This sort of non-addressable media, so think of the big offline channels like TV, radio, print. Another thing that can be added in here is not media, but things like promotions, right? So if a company uses a promotion over the course of a couple weeks or a month, we can include that in the model. It's much harder to figure out how to include that in a multi-touch attribution model. we get a sort of holistic estimate across all channels, which is kind of interesting. So with multi-touch attribution, one of the challenges that we've seen there is that everybody that we're sort of working with, we have some people who we reached and they didn't convert, some people who we reached with advertising and they did convert, but the estimates of how many would have converted without advertising are very hard to come up with because we need advertising in that path. We can approximate it, but with media mix modeling, we can estimate those quantities directly. So we can understand the overall effect of marketing, sometimes with greater or lesser accuracy, and we can understand the impact of each individual channel. The purpose of this is it would allow you to understand sort of the allocation of dollars across channels. So if you have, if you're a firm and you have an extra couple $1,000s to spend, should you spend it on search? Should you spend it on social media? Should you spend it on product listing ads on Google or Amazon? Or should you put it somewhere else? Media mix modeling is designed to answer that question, and it allows you to forecast what would happen if you put that $1,000 in paid search versus paid social, something like that. And then forecasting, again, is kind of one of the strengths of media mix modeling, the ability to do scenario planning, to see the interaction between channels, to understand the diminishing returns relationship between marketing spend and performance. All of these things are sort of part of the media mix modeling equation. The list of firms for media mix modeling is much shorter. So IRI, founded in 1979, was acquired just recently by Partners Group. We have the Kantar Group, which acquired Millward Brown, and it has remained independent, but it was founded in 1993. Market Share Partners was founded in 2005. It was acquired by Newstar. All right, like Newstar is like picking up players in different places. Analytics Partners was founded in 2000, and they remain independent. And I would say that they and Market Share are probably the two best practitioners of a product approach to media mix modeling. Marketing Evolution was founded in 2000, and they are independent as well. I actually began working with them through Atlas right around 2000. And so I have a question sort of for you, giving me a chance to pause and drink a sip of water. Why might there be sort of fewer players in media mix modeling, and why fewer acquisitions? What are the reasons why very similar technology companies, in one group, they might be just bing, 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 acquired all over the place, and in another group, they just sort of roll on, but they are not attractive acquisition targets? I mean, one part, I don't know if this expression is common in Montevideo, but FOMO, right? Fear of missing out is what we call it. And then we have now an analog of that, JOMO, the joy of missing out, because we're all so busy. But part of that might be fear of missing out, right? Some of the big firms, an AOL buying Convertro, right? I don't think AOL had any strategy. I'm not sure AOL has had very many strategies in the last 20 years, although I still have some of those discs they would send us. But AOL probably bought Convertro because everyone else was buying an attribution firm and they don't want to miss out. But what's another reason why these firms might be less attractive? Why do you buy a company? Yeah, to get access to the data, right? These companies are using data that is not that hard to get, right? Even these sort of strong performers, Marketing Evolution, Analytics Partners, Market Share Partners. Oh, interesting. It's like those words all sort of go together in a Venn diagram sort of way. But they're using data that isn't very hard to obtain. It's not sort of big data in the classical sense. And so the data itself is much less valuable. And then I would say the second piece is working with that data is much less scalable. For the companies on our previous list, you could build a product. The data all sort of look the same. The web logs have a regularized structure. And essentially, you put the web logs in, you turn the crank, and attribution comes out. Media mix modeling is not like that, right? For all of you in the room who do modeling, you probably know when you sit down to do sort of a big complicated regression model, they're all sort of unique snowflakes of beauty, right? Like they're tricks that you've used in the past and you can make things, you can borrow things from other places. But these companies have had a very hard time scaling through technology. So one is the data. Absolutely. The ability to have that access to that data, I mean, that is the reason why Facebook and Google have the valuation they do, is because of the data they have. And then the second thing is these companies have not been able to scale the same way. So as they grow larger, their headcount grows larger too. So it is not the same sort of return on investment for the acquiring companies. This is the picture from a couple years ago of the same, just last year, of the same sort of idea for the media mix modeling company. So we have Marketing Evolution and Analytics Partners. Analytics Partners, I agree with this sort of depiction. Marketing Evolution, they are gritty practitioners who are just trying to sort of make it happen. Analytics Partners, I think, has a little bit broader strategy. And if you are looking for sort of leadership in this space, I encourage you to check out their website. They have a number of nice sort of white papers, and I think they're doing interesting things. Newstar, it makes sense that they are right in the middle because they have acquired so many companies that I think their strategy is kind of a mixed bag. Their product offering is kind of a mixed bag, but it is strong and they will continue to be strong. So I'm going to shift gears here a little bit, and we're going to talk about some of the math behind this. Lest you be afraid that I'm going to show you a million equations because I love statistics, I will not do that because I am truly a practitioner at heart and a very applied statistician. So I want to just give you kind of a flavor of how we do the work we do with the data. And it's pretty easy in a sort of general sense to take what you see here and continue to sort of study the paths that we're following if you're interested in these topics. Let's see. So media mix modeling grew out of econometric methods, and you can think of it as sort of a classical regression technique. So, imagine we have maybe an indicator for the month of the year so that there's kind of an annual seasonal effect. We have an indicator for the day of the week because for many advertisers, the day of the week matters a lot, right? I worked for a B2B company, and it turns out that Saturday and Sunday are not very effective days to market. That was a big surprise. I charged a lot of money for that insight. Just kidding, you can't charge for that one. But then we might have information about different channels, right? So display advertising, organic search, paid search, social. And you put these in the regression machine and out comes coefficient estimates. The reality is that these models are more complicated in practice. The same idea is there, where we are looking at a model that includes, when I'm talking to clients and they say, what should I do? What do I need for a media mix model? And I say, let's just spend an hour in a room and let's think about everything that could be influencing people to purchase. And then which ones of those can we get data on? And then, sort of third, which ones can we get data on in a reasonable amount of time and money? And those are the things that we're trying to put into the model. So one thing that you really want to do is do some kind of transformation for diminishing returns. If you're looking for a simple way to think about diminishing returns, we have the square root rule. And that will do pretty well for you. The square root rule, the idea is that if you double spending, you don't double your response, right? You can't spend twice as much and get twice as much results unless you're a very new business. Instead, when you double spending, you get about the square root of 2 response. So about 41% more. But yeah, just to sort of draw the curve that I promised to draw you, but double 2 times spend is approximately square root of 2 times response. And you could probably figure out what 4 times spend would look like. And so if you ever have to think about diminishing returns, whoever's asking you to think about it, say, oh yeah, that's an interesting problem. I'll look into that. And then go to your office, write down square root rule, and then take the rest of the day off, and then come back the next day and say, yeah, I think I've got something. But we use sort of, we don't use just sort of written down heuristics, but we can estimate what that is. Is it really the square root? Is it more like the cube root? For some channels, it might be very flat, and we see no return for increasing spend. That's when you're way out at the tail of the distribution. In other cases, we're on such a steep part of the curve that it looks linear, really. We incorporate ad stock variables. And so ad stock is a term that has existed in marketing for a long time. And the idea is that when you put advertisements sort of out there in the world, they continue to have an effect, right? If I show 1 million ads today, then those 1 million ads, will they be influencing people in a month? Probably not. But will they be influencing people tomorrow? Probably. And where is that is kind of the thing we're searching for. And I've depicted some possible sort of ad stock curves. So this top one is just the raw spend. So this ad stock variable, I just modeled, I just sort of said, okay, let's imagine once a week we spend $10,000, right? In reality, the spend is happening every single day. You can have different kinds of decay rates. So this is a very slow decay, but only for 3 days. So if you spend $10,000, the influence is $9,000 on day 2, $8,100 on day 3. You could also have something that goes out for 5 days with a very steep decay rate. And this is probably something between these two is usually what we see. Here's another example of a more modest decay rate for a long period of time. And this one is interesting because it's hard to see, but these sawtooths kind of level up over time. The spend is coming in on top of the decay, and you can have this additive effect of advertising. And there are ways to estimate what the appropriate ad stock is at each step. And then finally, interactions. So there's sort of kind of simple interactions, the kinds of interactions that we think about when we talk about marketing, where we say, or modeling, display and video might have an interaction effect where if you look at the response from display and the response from video, there is some way they are interacting where maybe the combined response is lower or higher than what we would expect if we just added them. But then there are also sort of more complicated interaction effects. The most interesting one is around organic search. So organic search is when someone searches for a firm or searches on their keywords and then clicks not on the paid ads at the top and on the side, but lower down the page. So those are search ads that you don't pay for. And what we see is that marketing activity increases organic search. So organic search leads to response, but then also marketing channels lead to more organic search, which leads to more response. And then the marketing channels lead to response themselves. And so you want to, if you're going to do a good job, you want to model all of these things. The regression context, allows us to sort of hold all else equal. I am contractually obligated as a statistician to now say all models are wrong, some are useful, the famous George Box quote. But the idea is that we can sort of look at the independent impacts of each one of these channels. And then, I would just mention that the model complexity really demands some way for advertisers to work with it, right? If I just show you an equation like this and a big table of coefficients, academics, people like me when I'm wearing that hat, like we love that, right? We look at a table of coefficients, we're like, oh, this is so cool, this is just crazy. We show that to somebody in marketing and their eyes glaze over, like the people who had just like too little coffee this morning and are in this talk right now, and you're just like, whew. So one thing that I'm actively working on is how do I take this sort of complicated model that I'm really into and I do all this stuff with, and then I expose it to someone on the marketing side so that they can play around with it and they can kind of understand, oh, this is the impact of moving this, and simulation is a good way to do that. So this is a real-world example from a client where we have the spend in various channels. And so you can see this is display, paid search, paid social, and video. And so you can see with video, they've really just started working with video. And display and paid search has this crazy sawtooth pattern, right? That strong sort of weekly seasonality is because this is a business-to-business customer. And so they are selling to people who are not working on the weekends, so they don't want to spend any money on the weekends. And so you get this kind of crazy pattern. So you take that as the input, right, the marketing. You combine it with the response. In this case, they're trying to generate leads for their business. And we can look at leads for Asia and Pacific, EMEA, US and Canada. We also modeled Latin America, which I think they throw South America in Latin America. So for those of you from kind of the European side of South America, I apologize for that, and I will talk to them about it. But we look at what are the drivers of media, what is the response, and then this is one example of the output that we generated. So for display, you can see that they're kind of on the flat part of that curve, right? If the spin changed, increased by 50% or decreased by 50%, it doesn't change display that much. Paid search, they're on a very sort of steep part of the curve. This one is a little bit misleading. If you think about how paid search works, someone had to look for this, right? You had to say data visualization software, and then they had an opportunity to show you an ad, and then you clicked on it, and they had the opportunity to pay Google for that. So you can't really ride that curve of paid search. You can spend more per keyword, but you can't make people search. Paid social, though, you can spend more. And that is something that Facebook, if you are in marketing, Facebook will make it very clear to you that you can pay more, you can spend more on paid social. And then video, we have no idea what's going on with video. There's not a lot of data. The results are very flat. The CMO loves video, so I say, I think we need more testing. That's the thing you say as a consultant when you don't know what's going on. So for media mix modeling, each client is different in kind of important ways. These models tend to be quite custom. There are these sort of flexibility versus accuracy kind of trade-offs. So for the media mix modeling companies, if they want to be flexible and take in all sorts of data, right? One client is doing billboards, another client is doing bus ads, and another client is just doing digital. If you want one piece of software to give you a model for all of those, it is going to be very hard to have the most accurate model. And so that's one thing that we see in the kind of media mix modeling world. Some of the data may have very high latency, so it might be old, basically. For instance, the billboard ads, right? We say, all right, we're going to spend $1 million in 2019 on billboards in these 3 cities. Great. The billboards went up in Chicago on February 1st, in New York sometime around March. The data phases in, and then getting the results, knowing how many billboards were up and things like that could take months. And so often you'll see the media mix modeling companies only giving models every quarter, and it's not about the modeling. They could run the model every day probably, but the data takes a long time to flow through the system. And then we see highly variable levels of granularity. So how did your television in the US do is a very different question than how did your paid search in the eastern side of Montevideo on a Thursday do, right? And we're trying to sort of tease that out right now. So the question was kind of what's my experience including promotions as part of a media mix model? We always include it if you can. It's sometimes tricky to figure out exactly how it gets included, and often it's at a very high level, like the total percent of dollars that were discounted in a given time period, or maybe time period by geography. But it has a big effect. One thing that is interesting and that I don't have a great answer for is promotions almost always have a short-term positive impact, right? If you discount things, people buy. We are creatures of habit. The economists say we respond to incentives, and they're probably right. It is unclear what promotions do for lifetime value, and I think that's something that we'll be doing some research on collectively over the next sort of 20 years. If you promote, are you training people to wait for promotions, or are you cannibalizing future sales? Probably, like that sounds sensible, or maybe these are all net additional sales. And I don't think we have any answers for that. But we do include promotions in the model. And thank you for asking a question. So multi-touch attribution, I think we've been working on this problem for 15 years, and there are really sort of 3 main avenues that we are using to solve those problems. So most people in here have probably heard of logistic regression. So logistic regression or survival models, which are sort of a cousin of logistic regression. That's one popular method. Markov models, and we'll talk about that just very briefly. And then these sort of shapely values or game theoretic models are pretty interesting. I personally don't love them as a statistician and not an economist, but they have some good traction. So this is sort of what you might see coming out of a survival model. And what's depicted here, this is a chart from my dissertation, but what you see here are what we call sort of non-conversion probabilities. So we are looking at drop-off as people have more clicks. So if you have 0 clicks, then over time, there is a little bit of probability that you will convert, but mostly you won't. If you have 2 clicks, there's a much higher probability that you will convert. And so the idea is, let's look at the sort of survival event as somebody purchasing, and let's see how different marketing touch points change that probability. These are the log odds multipliers. So for those of you who come from kind of a modeling background, we see that a click has a huge impact on changing someone's response, right? That makes sense. If you clicked on an ad, you are very likely to interact with that business. Other things, text ads are less effective than display ads, a little piece of text versus some kind of image. Larger ads are more effective. That's what I found in my research. And then the more recent an ad is, the bigger impact it has. Again, these are not the sort of insights that you can charge a lot of money for. But if your advisors are in a math department, they're all like, oh, that's really cool. It's like, yeah, all marketers know this, but no mathematicians do. So I just kind of worked that middle there. So you can use survival models to look at multi-touch attribution. This is an amazing chart from actually a great paper, this Ender et al., Mapping the Customer Journey. I highly recommend it, partially because it talks about this Markov model approach, but it also has a great list of what do we want out of a multi-touch attribution algorithm. So objectivity, right? We don't want humans telling us kind of what's going on. Predictive accuracy, that makes sense. Interpretability, this is a big one, right? Can I run the model and understand what the drivers of conversions or purchases are? Versatility, so it should work with a lot of different kinds of input, and efficiency. Markov model, I think, is sort of iffy on efficiency, but you will not be surprised to find out that the authors think that their model checks every one of those boxes. That's, unsurprising. But what we have here is sort of a picture of a Markov model. The idea is that there are states someone can be in. So the state of just having seen display, the state of just having clicked on search, and then the state of purchasing or a null state where we don't see you purchasing. And we look at the transition probabilities between all these states to try to understand how someone purchases. One just side note for practitioners is it is a clear best practice to include higher order terms, so like lags of at least 1 step. The efficacy drops after that, but you really want to take into account not only what was the last touch point, but the touch point before that as well. So this is kind of the Markov chain methodology. And finally, game theoretic models. The idea is that we will look at some paths that have search and email, some that have search, display, and email, and we will try to understand how does the probability of someone purchasing change when display is present versus when it's absent. And there is a, what would you call it? I guess sort of a modeling approach called Shapley values. I believe Shapley won a Nobel for it, although if anybody is an economist and can actually tell me, I'd love to be less ignorant. Yeah, I would say that this is sort of popular in some segments. It's a really interesting methodology. It's really intuitive, so if you just like seeing neat math, it's pretty cool. It's tricky to include some marketing features. Shapley values are really cooperative games. So if we're all sitting around a table and we're trying to see how much money we've made in a cooperative game, and then I go away and you four just play, now we see how much money you make, and that can help us estimate the value that I am bringing to the table. It's a little bit harder to figure out how you would include things like, how recently did I leave the table? So multi-touch attribution, we talked about 3 methodologies. MTA gives you very granular credit allocation, lowest possible level of reporting. You are figuring out how much each touch point was worth. That's what you're trying to estimate. Missing data is a big problem. If you don't have certain data sets, you are not going to have good estimates, and you are going to inflate other kinds of estimates. And then the question I alluded to earlier, how would you forecast out of this, right? I would have to look at all possible future consumer paths and then maybe run them through my algorithm or something, and it's a very tricky problem. So now, kind of the emerging duopoly or triopoly. I've been calling it the emerging duopoly for a year. I think we're now ready to consider it a triopoly, so sort of a 3-party market. So let's talk about the players in the duopoly. So we've got Google. You've probably heard of them. John Battelle calls Google's data the database of intentions, right? The things that you want to do, Google knows about, right? Best coffee shop near Dazzler Hotel, right? Google knows what I'm interested in. They know where I'm staying. They know what I'm looking for. They're the worldwide leader in geospatial data. I mean, they are, in the US, they are well ahead of the government in understanding addresses, routing, all of that kind of information. And it makes sense. They've spent a lot more money than anybody else has on geospatial data. They have the best cross-device profile. Google knows more about multi-device usage than anyone else in the world, other than maybe the NSA. They have extensive device and browser history, right? Android, most popular phone operating system in the world. Chrome is sort of up there in terms of most popular browser, and they are harvesting all of that information. And then, God bless Google+. We missed you. But they failed in social media. And it's interesting, right? It's interesting to look at where firms like this fail because they don't have a lot of failures relative to their successes. So Facebook has the richest demographic data set ever assembled, right? And I have not gotten my thank you card, but I gave it to them, right? Like we all freely gave them that information. They're the largest media company in the world, and they don't produce any content. We produce the content for them. It's like good work if you can get it. And that's why Google tried to create Google+, is they wanted some of that data for themselves, and they were unable to do it, partially, I think, for missteps, partially for sort of network effects. They have second best cross-device understanding. They have no device, browser, shopping data directly, right? They plug in a lot of places in the web, and they are building up that data set, and they are continuing to work it. But the fact that you see the Facebook like button all over the web is not because they want to make it easier for you to like things, right? They want to know you are on that website. They want to see where you surf because there isn't a Facebook browser. And if there is, I wouldn't recommend using it. I don't trust either of them, but I trust Google more. And Facebook, and this is sort of down in the weeds a little bit, but Facebook has developed an incredibly strong A/B testing platform. The ability for marketers to say, hey, I'm going to give you $100,000, and I want you to run a test with that and tell me how well it worked. Well, sure, I trust you, Facebook, but I actually think they're doing the data science correctly. The reason why they've created that platform is because they have closed off their data so that marketers can really not see very much of what's going on in there. And so here's a picture of a garden in Dublin. I went there last year with my dad and siblings. But Google and Facebook walled gardens. They have different kinds of data, like fundamentally different kinds of data sets. They are both enormously valuable. Both companies have large data leakage teams. You know, when you hear data leak, you think, oh, they gave away all of our passwords. Yes, that is how we think of data leakage. When Facebook talks about data leakage, and they have a 50-person data leakage team, they are talking about not letting their data get off of the platform to advertisers. They are talking about not letting their data get off of the platform to Google or to somebody who could match it up with Google data. And that is what they are focused on. Neither of those companies is going to acquire the other. US regulators would never let it happen. Both sets of CEOs have too big of egos for that to ever happen, I think. So we'll never see this data merge. And I mean, from a human standpoint, thank goodness, right? If you're looking for a fun book, Dave Eggers' The Circle posits what a future might look like with Google and Facebook merged. It's grim. It was made into a movie too, I think. But neither will acquire the other, so those data sets will stay separate. And advertisers are caught in the middle. You have two giant companies with very valuable data sets who are working very hard to keep that data away from anybody else and monetize it. Facebook no longer allows impression tracking. Google never allowed impression search tracking. And the trend is less data sharing over time. Every time these companies can pull back data from advertisers, they are trying to do it. And the platforms are just like, don't worry your pretty little heads about any of this like hard math and data stuff. Just write us checks, we'll give you customers, and it's no problem, right? It's no problem until you want to talk to your customers directly. It's no problem until you do something to piss off one of these companies and they turn you off. And imagine what ORT's website would look like if Google no longer returned ORT links on searches, right? They could just turn off your internet, essentially. And so the platforms want to just write us a check, we'll give you customers, don't ask any hard questions. Marketers want to know what they're getting for their money and want independent verification. And so these advertisers are getting caught in the middle here. This is a chart from last week, and this is the market share for the big 5 companies in terms of advertising spending. So we have Google, Facebook, and Amazon. In red, we have the 2018 share of digital dollars. So 38%, Google was 38% in 2018, 37% in 2019. And you don't have to spend 17 years in math graduate school to figure out kind of where that percent went. A lot of it went to Amazon. 2 years ago, no one was talking about Amazon as a marketing player. Now everyone is talking about it. 50% of purchases start with an Amazon search. It's something like 30% start with a Google search, and then 20% start in other ways, which include going to the company's website. So Amazon, and that was a US figure, but Amazon is controlling the purchasing of items. So for some advertisers, Amazon is becoming a very important player. They are not transparent with data. They never have been. And so what we're seeing is an increasingly large share of advertising spending going to these 3 companies. Google plus Facebook plus Amazon, 68% of marketing spend. So for every dollar that is spent, 68 cents is going to one of those 3 companies. Every dollar spent online, 68 cents is going to one of those 3 companies. The relative year-over-year change is 2%. So it's an open question. Are they going to sort of cap out around 70%, or will they continue to take market share from other advertisers, other publishers, other places you can spend money? Who knows? I'm not a futurist, but I would bet that this continues. That means critical data is missing for multi-touch attribution. So multi-touch attribution, you want to have, remember the glory days of 2012. We're going to put tags everywhere. We're going to see every little marketing touch point. We're going to totally understand kind of what happened. Those days are done. I know it was a whirlwind, we had our moment and now it's gone. But critical data is missing for multi-touch attribution, and it's going to be missing more and more. And so the question is, what should we do? But we can get this granular non-user level data, right? Google and Facebook, they have to throw us a bone so we keep spending money. And so the way they're doing that on the advertiser side is they'll give you daily data by geography so we can get the raw materials for media mix modeling. And so the question we now have is, if you have $10,000 to spend, what platform should I spend it on, right? Facebook says Facebook, Google says Google. They will both give you data that support their side. But we can use media mix modeling to try to answer that question. So kind of in closing, the sort of place where I think we are now is we can have multi-touch attribution, which gives us very granular understanding of how advertising is working within a channel. So if you have to decide what keywords to buy on Google and optimize those keywords, you can use multi-touch attribution. You can use media mix modeling to take into account things like seasonality and economic indicators, offline media, video and TV, to try to understand business performance. And then the goal is to somehow knit those 2 things together in a way that makes sense. So our dream is to optimize at the lowest level of granularity possible, right? So that's what MTA gives us. We want to report at the lowest level of granularity possible, right? Because our bosses want to understand media working at a very low level. We also need to make trade-offs between these channels, and we want to provide forecasts and do scenario planning, and that's what media mix modeling gives us. And so that plus sign in the middle of the previous chart is really key. How do you glue these together? And nobody knows the answer to that question. So that is really kind of what I'm working on these days, and what like a lot of people who kind of do what I do are working on, is how do we knit those two pieces together? So kind of in conclusion, I think, and other people who are smarter than me have said this, Facebook, Google, and Amazon is going to equal the death of pure MTA. You can no longer just use multi-touch attribution to make sense of marketing analytics. MTA is good within the channel. Media mix modeling is good across channels and good for forecasting. And knitting them together is the thing we're kind of currently working on. So that is what's going on in marketing analytics. So thank you very much for your attention. I appreciate it.